So, good afternoon, my dear friends. Welcome to online classes from MGVC Arts, Commerce, and Science College, Madhya Bihar. So, it's Department of Chemistry, and myself, Professor UMARFAROOQ HALYAL. Today, I am going to take for your BSc first sem. The topic is chemical bonding. So, in previous class, we already discussed regarding to what is mean by chemical bonding and the types of chemical bonding. And today we are going to discussing about the new bit of this unit, that is lattice energy. So lattice energy means this is the energy required to completely separate one mole of a solid ionic compound into its gaseous state or gaseous ions, or we can also be called as the energy released when an ionic solid forms from its ions. Means, suppose, see example of sodium chloride formation. Sodium chloride having the cation and anion. Here cation is Na plus and anion is Cl minus. When these two are present in the gaseous state, so these two are then converting into NaCl, that's in the solid state. Here some amount of energy is released. So this released energy is nothing but lattice energy. So this lattice energy we can be calculated by two methods. One is Born-Lange equation, that is a theoretical method, and the next one Born-Haber cycle, it is experimental method. So now moving for Born-Lange equation. So this Born-Lange equation is based on the Coulombic interaction within the ionic crystal. Means it is the electrostatic force of attraction between oppositely charged ions. Means the cations and anions present in a molecule compound, when they both are attract each other, we can fit in the Born-Lange equation. Suppose some repulsive interaction due to interpenetration of electric charge clouds. In this case also we can use the Born-Lange equation. Based on the above two interaction, the Born-Lange equation we can write in the theoretically for the calculating of lattice energy is as below, that is U is equal to minus N naught A into Z plus into Z minus E square divided by R naught into 1 minus 1 divided by N. So this equation we are going to call as Born-Lange equation. See the equation again. U is equal to minus N naught A into Z plus Z minus E square divided by R naught into 1 minus 1 divided by N. And the notations are where N naught is nothing but Avogadro's number. The value of Avogadro number we know, that is 6.022 into 10 raised to 23 per atom. And A is nothing but Madelung constant. Z plus is charge on cation, Z minus charge on anion, E or E minus, that is electronic charge, R naught, that is the sum of radii of cation and anion. N is nothing but this, it is the Born exponent, that is greater than 1. So these are the notification we are using in the Born-Lange equation and their meanings. Now moving for significance of Born-Lange equation. From the first significance, use nothing but for lattice energy. So this lattice energy is directly proportional to Z plus and Z minus. Z plus and Z minus, these are the charges of cation and anion. When the higher the charge of cations and anions, the greater the magnitude of the lattice energy. So when the charges of the cation and anion increases, on that case the lattice energy is also going to increases. And the second significance, U, that is lattice energy is indirectly proportional to R naught. R naught is the radii of the molecule. When the smaller the size of the ions, the higher the lattice energy. When the size of the atoms or ions are small, on that case the lattice energy will be going to higher. Suppose the higher the size of the ions, in that case lower the lattice energy. Examples are there, that is lattice energy of sodium fluoride is greater than lattice energy of sodium chloride, that is greater than lattice energy of sodium bromide, and that is greater than the lattice energy of sodium iodide. Now moving for the important bit of this unit, that is the Born-Haber cycle. As we know, lattice energy will be calculated by two methods. The first one is Born-Land equation. So that Born-Land equation may be asked for your exam purpose for 2 marks. And the next method, that is the Born-Haber cycle. This will be asked for 5 marks. So this direct experimental determination of lattice energy is difficult, so hence determined indirectly by a cyclic process called Born-Haber cycle. So these two scientists, Born and Haber, in the year 1919 they invented this cycle to calculate the amount of lattice energy of a compound. And this Born-Haber cycle that relates the ionic compound, that including sub steps, they are like sublimation energy, ionization energy, electron affinities, dissociation charge, and other atomic and molecular properties. So this cycle is based on the law, that law is Hess law, that states that the total amount of heat evolved or absorbed in a chemical reaction is constant, whether the reaction is carried out a single step or multi-step. Means whatever the amount of heat evolved or absorbed in a reaction, that will be constant, whether that the reaction we are undergoing a single step or that reaction will be in the multi-step. So generally Born-Haber cycle we are going to describe by this method, that is M, that means metal that is in the solid position, plus half x2 that is in the gaseous, and that gives us mxs. Here the change in delta HF naught means it is the change in heat formation or enthalpy formation. Here we have to solve that. The first step, there is a change in the sublimation, that gives us M gaseous. So that sublimation M gaseous, when undergoing ionization energy in the second step, that gives M plus, means that is in the cation in the gaseous phase. When we are going to second ion, that is the cation anion, that undergoes delta H dissociation, that gives us X gaseous. So that X gaseous undergoing electron affinity, that gives us X minus G, means X anion in the gaseous phase. And these M cation, that is in the gaseous, X anion, that is gaseous phase, we are undergoing lattice energy that gives us our product MXS. So see here, delta HF naught is equal to delta H sublimation plus ionization energy plus change in the dissociation energy plus electron affinity and plus lattice energy. This is the general method we are going to use to calculate Born-Haber cycle, but particularly we are going to use sodium chloride as a perfect molecule to calculate Born-Haber cycle. So this is the indirect route of reaction for sodium chloride. Just you saw that. First step, that is sodium plus Cl, sodium plus Cl minus, that gives NaCl, that is in the solid. In that after that we are going to atomize solid sodium, means Na that is present in the solid state, that gives us Na into gaseous phase. Here the change in the enthalpy is plus 108 per mole. And the second stage, the chloride gas is going to atomize, that Cl2 is converting into Cl in the gaseous stage. The change in enthalpy, that is plus 121 per mole. In the third step, that sodium atom is converting into sodium gas. Here change in enthalpy is 498 per molecule. And the fourth step, that chloride atom is going to converting for chloride gas, that is Cl is converting Cl minus. Here the change of the enthalpy is minus 351 per mole. And finally, when we are going to combine all these reactions, we get Na, that is in the solid state, plus Cl2, that is in the gaseous phase, that gives us NaCl solid. Here delta H lattice energy is equal to minus 787 per mole. So sum of the indirect route equals to minus 411 kilojoules per mole. Hence the standard enthalpy change of the formation of sodium chloride is minus 411 kilojoules per moles. Means in some reaction we are going to write minus 411 kilojoules per mole, and some reaction we are going to write minus 787 or 788 kilojoules per mole. But this is the standard enthalpy change for the formation of sodium chloride, that is minus 411 kilojoules per mole. So this is the reaction process, Born-Haber cycle for sodium chloride. Here sodium plus, that is how to convert by changing step by step lattice energy to their and lattice enthalpy changing, then electron affinity changing, and the bond dissociation enthalpy, that is half delta H naught Bd, that is plus 121.5, that is changing. Then the sublimation enthalpy, that is also going to change here. And finally we got sodium chloride. This is the Born-Haber cycle for sodium chloride. So this is enough for today's class. So next class we are going to for the next topic, and please subscribe to my YouTube channel and like my videos. So stay safe, enjoy the classes. If you got any queries regarding to this video or any other questions regarding to our syllabus, ask me to my WhatsApp personal number. So take care, bye.